When we create a truth table for a statement, one of three things will happen. And each of these three possibilities has a name. The first possibility happens in this first example. We're asked to make a truth table for the statement P if and only if, not in parentheses Q or P. How do we make a truth table for this? Well, we start with negations of simple statements. We don't have any of those. Then we start with the innermost set of parentheses. We only have one set of parentheses here. It's Q or P. So to figure out the truth values there, we're doing OR to the Q column and the P column. So when they're both true, OR is true. When only P is true, OR is true. When only Q is true, OR is true. But when they're both false, that's when OR is false. Okay, we've finished all the parts in parentheses. Now we look for negations of anything we've already symbolized. Well, we have the negation of that Q or P. So next we'll have not Q or P. And at this point we're doing not to this column. So when Q or P is true, do not to that, we get false. True, do not to that, we get false. True, we get false. False, we get true. Okay, there are no more negations of things we've already symbolized, and in fact, in this example, all that's left is the full statement. So all that's left is P if and only if this whole thing. We want to do if and only if to the P column and to the not Q or P column. If and only if is true when they have the same truth value. It's false when they're different. So true if and only if false, that's false. True if and only if false, also false. False if and only if false, those are the same, so that's true. False if and only if true, again, that's false. So what do we see in our final result column here? Well, we see that our final statement can be either true or false, depending on the truth values of P and Q. And that is kind of the normal thing for a statement to do. A statement that does this normal thing, where it's got trues and falses in the final column, that statement is called contingent. A contingent statement might be true, it might be false. Okay, well, what's the alternative? There are two alternatives. We see the first one in this next example. We'd like to create a truth table for the statement, if P and Q, then P. So again, we start with negations of simple statements. We don't have any of those. Then we start with the innermost parentheses. We only have one set of parentheses, and that's P and Q. To fill in that column, we want to do and to the P column and the Q column. And is true as long as both of them are true. So when P is true and Q is true, and is true. True and false, that gives us false. False and true, that gives us false. False and false, That also gives us false. Right? There's only one true. It's only true when both of them are true. Okay. Now we want to look for negations of anything we've already symbolized. And looking at this statement, we see pretty quickly that all that's left is to go to the full statement. So the full statement, we have P and Q, then P. So we want to do if then, with this as our if column, and this is our then column. So let's recall, if then, when the if part is true, the then part has to be true. When the if part is false, the if then is true automatically. So if true, we need to look at the then part. True, the if then is true. When the if part is false, if then is true automatically. If false is true automatically. If false, it's true automatically. We notice, when we look at this column, that our statement is always true no matter what. No matter what truth values P and Q have, our final complicated statement is always true. That's a special thing, and it has a special name. That's called a tautology. A statement that's always true no matter what is called a tautology. The last thing that can happen, I bet you can predict it, happens in this last example. So we're going to make a truth table for this. We'll start with negations of simple statements. Oh, here I see I'm negating P and also negating Q. So I'll have two of those. Not P, not Q. Not P has the opposite truth value of P, so not true is false. Not true is false. Not false is true. Not false is true. Not Q has the opposite truth value from Q. So not true is false. Not false is true. Not true is false. Not false is true. All right. Next we go to the inmost set of parentheses. Well, we have two sets of parentheses here, P and Q, not P or not Q. Those are at the same depth, right? They're not one inside the other. So we can do those in either order. We'll have P and Q. We'll have not P or not Q. For P and Q, we're going to want to do and to the P column and the Q column. So and is true when they're both true. So true and true is true. True and false is false, right? They both need to be true for and. False and true is false. False and false, still false. For the next column, we have not P or not Q. So we want to do or to the not P column and the not Q column. So false or false, that's false, right? For or, at least one of them needs to be true. False or true, that's true. True or false, that's true. And true or true, that's also true. Okay, now we want to look for, it's easy to see that there's nothing left but the whole statement. So here, we want to do if and only if to these two columns. If and only if, that's true if they have the same truth value. It's false if they're different. True if and only if false, that's false. False if and only if true, that's false. False if and only if true again, still false. False if and only if true again, still false. So looking at this column, we see that this statement is false no matter what. This statement is false no matter what P is, no matter what Q is. When we have a statement like that is false no matter what, that is called a contradiction. So these three categories, contingent, could be true or false. Tautology, always true. Contradiction, always false. These are going to turn out to be something to be on the lookout for when we're doing analysis. We want to be careful when one of the statements involved is we will need to be careful when one of the statements involved in an argument is either a tautology or a contradiction, because strange things happen under those circumstances.